Hello everyone, welcome back to another banger video. Today, we're going to be building an exciting project that involves predicting loan approvals using machine learning. Predicting loan approvals is a common task in the finance industry, and in this tutorial, we'll leverage machine learning to build a loan approval prediction model. By analyzing various factors such as income, credit history, and property location, we can make accurate predictions about whether a loan application will be approved or not. By the end of this video, you'll have a solid understanding on how to implement this solution using Python and scikit-learn. Now, before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out of the way, let's hop right into it. So before we begin, let's ensure that our environment is properly set up. We'll need several libraries including pandas, numpy, matplotlib, and seaborn. If you're on the desktop version of Jupyter Notebook, you can go ahead and install those now. If you're on Colab, let's just go ahead and import them. Right, the next thing we're going to want to do is load our dataset. So an easy way to do that on Google Colab is just to type in this code right here. This will prompt a little icon here where I can choose files. Go ahead and select our file. If you're on the desktop version of Jupyter Notebook, you just have to drag the dataset into your repository or into your directory, and then you can go ahead and call it from there. The dataset for this project will be linked in the description. Just go down there, download it, and then you can use it. And now let's go on to actually loading the dataset. Alright, so in these code snippets, we import the necessary libraries, pandas, numpy, matplotlib, and seaborn. We then use the pd.readCSV function to load the loan approval dataset from a CSV file called loanapprovalprediction.csv, which is the one linked down below, and then we assign it to the variable data. Finally, we use the head function to display the first 5 rows of the dataset, giving us a glimpse into the data structure. Now that we have loaded the dataset, it's time to pre-process it before training our machine learning model. Let's proceed with the code. Alright, so in this code snippet, we use the dtypes attribute of the data frame to check the data types of each column. We create a Boolean series object that identifies the columns with the data type object, which typically represents categorical variables. We then use the list object right here, .index, or this specifically in here, to get the column names of the categorical variables and calculate their total count. This information helps us understand the data's composition and identify which features require special treatment during preprocessing. Parentheses here. In this code snippet, we drop the loan ID column from the data frame as it's not relevant for our loan approval prediction task. We can use the drop function and specify the column name to be dropped along with the axis equals 1 parameter, which indicates that we want to drop a column. The in-place equals true parameter ensures that the changes are made directly to the data frame. Right, let's run that and move on. Alright, so in this code snippet, this allows us to visualize the categorical variables using bar plots. Let's go ahead and run it, make sure we didn't make any errors. So here we create a Boolean series, which is obj for object, to identify the columns with the data type object. We then create a list object calls for containing the column names of the categorical variables. Next, we create a figure with the 1836, with the size of 1836 using the PLT figure fig size 1836. We use a loop to iterate over each column in object calls. Inside the loop, we calculate the value counts of each category using column in the column using data called .value counts, the function, and assigning it to y. We then create a subplot using the plt.subplot function and specify the position of the subplot in the grid layout. And finally, we create a bar plot using sns.barplot with the x-axis values as the categories, list, y index right here, and the y-axis values as the frequency counts, or just y. The PLT x-ticks rotation equals 90 line ensures that the x-axis labels are rotated for better readability. To train our machine learning model, we need to encode the categorical variables into numeric form and analyze the correlation between the features. Let's go ahead and do that now. Alright, so here we import the preprocessing module from scikit-learn to perform label encoding on the categorical variables. We create a label encoder object and store it in the variable label encoder. We then create another Boolean series object to identify the columns with the data type object. Using a loop, we iterate over each column name in object.object.index, and for each column, we use the fit transform function method of the label encoder object to encode categories into numeric values. We update the data frame with the encoded values. Let's run this, make sure it works. So after encoding, we again check the number of categorical variables using the same approach as before. This ensures that all the categorical variables have been successfully transformed. Alright, so now we're going to go ahead and visualize the correlation matrix. Alright, so here we create a correlation matrix using the core function method on the data frame. This matrix measures the pairwise correlation between different features. We visualize the correlation matrix using a heat map, which provides a visual representation of the correlation values. We use plt.figure fig size 12.6 to set the size of the figure. Then we use sns.heatmap to create the heat map, specifying the color map cmap brbg, the format of the values, which is fmt equals 0.2 f for 2 decimal places, the width of the line separating the cells, so that was 2 here, and to whether to display the correlation values as annotations, which annot equals true does. Alright, now we have our data pre-processed. It's actually time to train and evaluate our machine learning model. Let's go ahead and do that now. Alright, so now we're gonna split the data into training and testing sets. Or let's go ahead and run this, add it to a different block. Make sure that's good. And now we're gonna go ahead and initialize the classifiers. Set the neighbors to 3 for the K and N. Alright, and now we're going to, and estimators. Oh, I forgot an S, should be N estimators. Alright, there we go. Alright, so now we're gonna go ahead and actually train and evaluate our models. So first thing we're gonna do is import an imputer to make sure that this works with random forest. Right. And then we're just gonna go ahead and impute the missing values. Alright, go make sure we didn't make any errors. Looks good. And now we can go ahead and train and evaluate our model. Right, let's make sure it's good. Alright, so we do get pretty high accuracy scores. Now or this is for training, now let's go ahead and actually evaluate the models on the testing set. Alright, so in this code snippet, we import the necessary modules for model selection and evaluation from scikit-learn. We split the data into training and testing sets using the train test split function with the test size parameter to 0.4, which is 40% of the data for testing. We did 40% for this because the dataset was smaller than other datasets that we've worked with in the other machine learning videos. So we did 40% just to make sure that the testing set is different than the training set. We then train each model on the training set using the fit method, passing in the features xtrain imputed and the corresponding label is ytrain imputed, and we make predictions on the training set with the predict method and then store the results in ypred. We calculate and print the accuracy score of each model using metrics.accuracyscore function. Next, we repeat the same process for the testing set. We fit each model on the training set and predict the labels for the testing set, then calculate the accuracy score. This allows us to evaluate the model's performance on unseen data. Alright, and there we go. We successfully built a loan approval prediction model using machine learning techniques. We've covered data preprocessing, encoding categorical variables, analyzing correlations, and training multiple models for evaluation. Alright, if y'all found this video helpful, drop a like down below, drop a comment, subscribe for more, and we'll catch you in the next one.